Welcome to my channel, viewers. To all the viewers, see here is three problems very important for the competitive exam for joint IIT and advanced JEE advanced. Okay, and very interesting problem, and it is most helpful for the finding the different type of summation. Okay, now see, this is the first problem. Here is question number 1. That is n equal to 1 to infinity and cot inverse to n square, and we have to show this is an pi by 4. Now summation n is equal to 1 to infinity, and it can be expressed as tan inverse, that is 2 by 4 n square, and again we write here n equal to 1 to infinity and tan inverse, this is here 1 plus 2n plus 1, and this is here 2n minus 1. Okay, now their subtraction would be here 2n plus 1 minus 2n minus 1. Okay, it can be expressed like that. Tan inverse n equal to 1 to summation n equal to 1 to infinity, and tan inverse that is 2n plus 1 minus tan inverse 2n minus 1. Okay, now if we put here 1, so we get here tan inverse 3. Okay, and now minus tan inverse 1. If we put 2, then this is tan inverse 2 to the 4 plus 5, so plus 1 is a 5, and this is tan inverse, if we put here 2, 4 to the 2 minus 1 3, and also put here 3, if we put here 3 to the 6 plus 1 7, and now this is a tan inverse this is a tan inverse 3, so this is a 5. Okay, now this is a limit n tends to infinity. Okay, this is limit n tends to infinity. Now this is at the ending term, that is tan inverse 2n plus 1 minus tan inverse 2n minus 1. Okay, now here n tends to infinity. See, okay, tan inverse 7 cancel to the next term, so this is here exists, and see carefully, this is tan inverse 2n plus 1, and this would be cancelled by the previous term. Okay, so therefore limit n tends to infinity and tan inverse 2n plus 1 minus pi by 4. Here is infinity, we put here infinity, so that is tan inverse infinity, so it can be expressed as pi by 2 minus pi by 4. So this is equal to pi by 4. Okay, so this is your answer. And for the second, same technique we have to follow the question. Here see, summation actually n equal to 1 to n, and now here is this is r equal to 1, to n. Now this is here 1 by 1 plus r into r plus 1, and this is r, to n. So summation r equal to 1 to n tan inverse r plus 1 minus r whole divided by r plus 1 into r. It can be expressed as like summation r equal to 1 to n and tan inverse r plus 1 minus tan inverse r. Okay, now putting r equal to 1, then we got here tan inverse 2. This is tan inverse 1. Again put 2, then we got 3 tan inverse 3 and tan inverse, sorry, okay, 2. Again 3, if we put here 3, got here 4, 3, this is 1, we put here 2, now 3, so tan inverse 4 and tan inverse 3. So up to n tan inverse n plus 1 minus tan inverse n. So this is least and this is in case of n plus 1. So this is the ending term. So this is already exists. So this is the minimum term. Okay, these two are cancelled. This tan inverse 2, tan inverse 3 and tan inverse 4 are cancelled for the next term. So these tan inverse n are cancelled to the previous term. So we have left here tan inverse n plus 1 minus pi by 4. Okay, so second is also complete, and hence deduce from that, therefore summation r equal to 1 to infinity and tan inverse 1 by 1 plus r square, that is limit n tends to infinity, n tends to infinity, and this is summation r equal to 1 to n, r equal to 1 to n, and tan inverse, this is 1 plus r square, that is limit n tends to infinity. So these values here tan inverse n plus 1 minus pi by 4. As n tends to infinity, we would have this is tan inverse infinity. So tan inverse infinity means pi by 2 minus pi by 4. It will be pi by 4. And now for that, now we have factorize r to the power 4 r square plus 1, that is r square plus 1 whole square minus 2r square plus r square. So r square plus 1 minus r square plus 1 plus r. Okay, for the third question, see summation r equal to 1 to n, and this is here tan inverse 2r by r to the power 4 r square plus 2, that is summation r equal to 1 to n tan inverse 2r and 1 plus r to the power square r plus 1 in r to the power square plus 1 minus r. Okay, from this, so r to the power 4 r square plus 1 is equal to this, and plus 1, this is 2, so this is equal to summation r equal to 1 to n tan inverse, you can write r square plus 1 plus r square minus r plus 1 all divided by 1 plus r square plus r plus 1 r square minus r plus 1. Okay, see, and this is equal to summation r equal to 1 to n tan inverse r square plus r plus 1 minus tan inverse r square minus r plus 1. Okay, if we put 1, then we get here tan inverse 3, 1, 2, 3. Okay, now this is here 1 minus 1, this is here 1. Okay, this is r equal to 1 to n plus, if we put 2, 4, 6, 7. 2, 4 minus 2, 2 plus 1, 3. If we put 3, 9, 10, 13. 3 square 9, 10 minus 3, 7. So plus tan inverse up to n, so that is n square plus n plus 1 tan inverse n square minus n plus 1. Okay, so 3 tan inverse 3 cancel, tan inverse 7 tan inverse 13 cancel to the next term, and these negative term are cancelled to the previous term. So we have left here only tan inverse n square plus n plus 1 minus tan inverse 1, and this is equal to tan inverse n square plus 1 minus pi by 4. Okay, I think all of you have better understood. Very interesting question, these three. Okay, see. Okay, now this is your answer. Second question, this is the third question, and this is your first question. Okay, bye everybody.